Welcome to Dr. Pat TV, and this topic is going to be about related rates. Basically, this is just a math way of saying word problem, special type of word problems. So, hey, I got to apologize, but that's what we're going to be doing. So, applications. Okay, now, but before we get to the related rates and doing some applications, some word problems, what I kind of want to do is just talk about the math behind it. How do we actually do the math for when working with these types of problems, related rates? So, related rates are basically going to be a situation where we start with a couple of variables, like we have formulas, and then we're going to throw in a third or a fourth related variable, a different additional letter that we're going to be working with, and that's where the related come parts is everything's going to be related. So we start with a couple nice cool formula, but then we throw in a third variable that's not even in the formula to begin with. And so that's the relationship part coming when we talk about related rates. I'll give you some examples in the next part of the actual word problems, but before we do that, let's start talking about the math behind it. Now, to do this, let's kind of look at our power rule and chain rules. You may recall our nice power rule basically says bring down the power and multiply the power and then subtract one from the power. So it's a nice two-step process. All right, and so then we also have the chain rule here, which is basically saying we work from outside to in, take the derivative of the outside piece, and then leaving the inside alone, and then multiplied by the derivative of the inside. So those are kind of the two things, the two main concepts that I just kind of want you to bring to mind, and that we're going to be playing with this. We're just going to kind of make a variation of this. All right, so the two-step process for that power rule, we've got multiply by the power, and we got subtract one from the power. Okay, so that's the power rule. Now I got to come out and make this apology to you because yeah, it is a two-step process, but I'm actually going to say there's a third step we didn't do before when we first started doing derivatives and power rule, but it's kind of there. And the third step that I want to talk about is you do the derivative of the variable. Okay, so there's this unseen step that we didn't talk about before, but it's actually there. And so I'm showing it to you on the right hand side. So I'm taking a variation. I'm starting with the regular power rule, and then I'm going to throw in this extra component that is very related to the chain rule. So what I'm doing here is combining together the power and the chain rules thrown in this third steps. So technically, when we do the derivative, we do the derivative like we normally do. We do the power rule. We're doing those two steps. But then we actually do the derivative of the variable. Now, why didn't we do this before? Well, hopefully you can look at in pink here, this dx over dx. What's that worth? So whenever we have a fraction with the thing on top and the thing on the bottom, the numerator and the denominator are the same. Basically, the overall value of that stuff in pink is just basically 1. So we're multiplying by 1. So big deal. So we didn't do this before is because we always ended up, we had formulas with x's in it, and we took the derivative with respect to x. We took the derivative with that dx on the bottom. That's what we say with respect to. So we were doing that. We had formulas of x's. We were doing derivatives in terms of x's. Everything was fine because in the end, it was dx over dx. There was a 1 there. Okay, so the variation I want to show you is this. What happens if I want to do the power rule here, but instead of doing it in terms of x, I'm doing it in terms of t down there. So down there I've got a t there instead of an x. I have a formula with x, but now I've got the derivative with respect to t. And then remember, n's just a number, it's just a power that we're playing with. So I'm playing with a t down there instead of an x. How does that change things? Well, we're going to do the same thing. We're going to do our power rule like we did before. Going to bring down the power. We're going to subtract 1 from the power. But in the additional step here in pink here, I've got the derivative of the variable, the dx dt. Well, It's not the same thing on top and bottom, so I can't just kind of ignore it this time. It's not 1, so I've got to keep it there. I have to deal with it. Give me some information about the value or the formula for dx dt, and I can put it in. But I can't just ignore it this time. So that's the main difference, that when we're playing with related rates, our derivative has an extra piece to it that we didn't have before. Okay, let's do a couple examples just to kind of get at this idea of what I'm really talking about. Okay, so the key point there, we can do the derivative using different variables. So I just want you to know that because I've got a t down there, it doesn't mean I got to stop. We can actually still do the derivative. Okay, so now an example. Okay, so I've got a formula here, 3q to the 4th plus 7q minus 12. It's all in terms of q's, but my derivative down here is a t. We're doing the derivative of a formula with q with respect to t. All right, in terms of t. And so how do we play the game? Well, basically, we're going to do the derivative exactly like we did before. I'm going to bring that 4 down, the 4 right here. I'm going to bring it down in front, multiply the 3. That's where the 12 comes from. Then I'm going to take that 4, I'm going to subtract 1 from it. And so then I get a power 3, and I've got my q. So basically, that first step, exactly like we've done before. But with the additional chain rule part, like, wait a minute, I've got a letter q here, I got a variable q. I'm doing a derivative in terms of the variable t. So since those are not the same, I've got to incorporate, I've got to keep track that, wait a minute, chain rule says do the derivative of the variable piece. And so I've got a dq dt hanging around. Then we do the derivative of 7q, just like before, whenever we had a variable to the first power, understood first power right there. And so that would be the derivative of 7q would be just a nice 7, but then times the derivative of the variable itself and the dq dt. And then the last step is the derivative of a constant. What doesn't matter what letter, what variable you're using, the derivative of a constant is going to be 0 here. So basically that's the shortcut, or not the shortcut, that's basically what we have there. The derivative of a constant is 0. And then if you wanted to, you could factor out a dq dt. It's just like any other piece of things that we can manipulate. So algebra-wise, we can factor out. Both these two terms here have a dq dt, so we could factor them out. And so that's another way of writing that expression. We have the ability to factor out in case we wanted to solve for dq dt in the future. Okay, so basically there's our first example of doing the derivative with respect to a different variable than what we have in the formula. Another example I want to use is that nice business example. Revenue is price times quantity. And what I want to find here is, what's the derivative of this formula with respect to t? So I've got a time component to my revenue, my price, and quantity. There's time involved in there. And so when doing this derivative, okay, so on the left-hand side, I'm just doing a rewrite. I'm just doing derivative of revenue. That's the dr part on top. So on the top of this fraction over here on the left-hand side, dr, that's the derivative of revenue. And then the dt down here is with respect to time. Okay, and so then on the other right-hand side, well, I've got two things multiplying together. So to do its derivative, we got to do the product rule. So basically what I'm looking at here is when I see P times Q, I've got to do the product rule, which says do the derivative of the first thing, in this case P. So I'm going to do the derivative of the price, that's the dP dt. So I'm doing the derivative of the first piece, leaving the second piece alone, and then plus first piece left alone, the first component there, first factor left alone, and then times the derivative of the second variable there, the dq dt. So basically I'm doing the derivative of each one separately while I leave the other thing alone when we do that. And so that would be the derivative of our revenue with respect to time, a new variable. We start with three variables there. We've got revenue, we've got price, time, price and quantity, and then we're doing the derivative with respect to a completely new related variable in such as time. And so that's where we get related rates from, is because we have a normal situation, we have a formula, and now all of a sudden we're doing the derivative with respect to a different variable, one that is related to the formula that we have, to the variables in the formula. Okay, so that kind of starts off, just gives an introduction of the actual crunching of our related rates. So what we're going to do next is some examples, actually some applications, some word problems. So we'll see that in part two. Thanks. Have a good time.